Okay, everybody's type of problem graphs, but this one's really not bad. The point we're trying to test here is, do you understand the relationship between these various graphs? And looking at the information, we want to determine the velocity and acceleration of the object at time equals 8 seconds. Alright, so we don't want to determine that value and that value on our graphs. Okay, we are given 82 is the position, final, 10 is the initial position, 4 is the initial velocity. So you could actually use those numbers in constant acceleration equations because you see constant non-zero acceleration down here on this graph. And let's talk about the graphs and what the relationships are. Probably the key point to see is that the velocity graph, this area right here, just label that A, is equal to the change in position. Okay, so if that area is a change in position, that's equal to, we started at, or ended at 82, we started at 10, so that's going to be equal to 72 meters. That's probably the key point here. We can calculate the area. We know the initial point. We know it's a trapezoid. We're going to try and find this V. I'm going to label it V sub 8 here. Alright, so that's to find that area, we can use the area of a trapezoid is 1/2 the initial point, which is 4, plus V sub 8, that's what we're trying to find, times the base, which is 8 seconds. Okay, so we set that equal to 72. So we have 72 is equal to 1/2 4 plus V sub 8 times our 8. And we can solve for V sub 8. So I shall do that. Oh, let's see. So we're going to have 72. We're going to multiply both sides by 2. We're going to divide both sides by 8. And we're going to, I'll get that, and we're going to subtract 4 off of that to get our V sub 8. So V sub 8 equals 14 meters per second. That easy. Okay. Halfway there, 14 meters per second. Okay, remember acceleration is just the slope of the V curve. Now that we know that V sub 8, so we could write that as change in velocity or change in time. That makes sense too. V sub 8 minus V0 over 8. So that's 14 minus 4 over 8. It's 10 over 8, or 1.25. That's going to be units of meters per second per second. So we're done. So acceleration 1.25 meters per second squared.